Thank you for joining our discussion, Craig.
Great to be here.
Railroads cross the nation, built on all types of terrain. Recent wildfires have become more damaging, especially in areas where heavy vegetation meets human habitation. You have conducted many field experiments to better understand wildfire behavior. How does wildfire behave?
Well, that is a question that many scientists around the world have been working on for decades. And it is a function, fire behavior is a function of basically the topography, the weather, and the fuels. And if I may share a slide here, let me go to share my screen real quick. This is the fire environment, and you can see that the weather is really the most dynamic of the three. So when we think of the fire environment, we refer to this fire behavior triangle and we think about topography, fuels, and weather. The fuels are really important because those are, if they're really close to structures, whether it's a infrastructure like power lines or a housing community or a railroad, they can impact that structure if they're depending on their condition. And we look at the fuel moisture and we look at how much loading, and what that is how much mass there is. So is there a lot of brush? Is there a lot of stuff to burn? That's why we have to do a lot of clearing around roads, around communities to reduce the amount of fuel loading. The more stuff, the higher intensity the fire will be. The drier the fuels are, the higher intensity will be. So that is a big issue. That's a big component of how fires behave. Another thing is topography. Areas of steep terrain, fires burn more erratically. They burn faster uphill than they do on flat terrain. So there's been many instances where firefighters have been entrapped in canyons because canyons are so dangerous. So if there's infrastructure in mountainous terrain, it just depends on how that fire will behave in each individual canyon, on slopes and such. So there's a lot of different ways that fires behave, but we can always come back to this fire behavior triangle, whether it's weather driven, topography, or fuels, or combination of all three.
What kind of technology do you use and what have you learned from it?
So at San Jose State University, within the Wildfire Interdisciplinary Research Center, we have a number of different tools that we use for understanding fire behavior and fire risk. Some of those include high resolution numerical models, so forecasting systems. So we operate a forecasting system that covers the whole United States, and it's very advanced. It's a coupled fire atmosphere model, which allows us to look at how the fire impacts the weather and how the weather can then drive the fire. And so that model runs operationally, which means that we run it in a forecast mode, kind of like the Weather Service, but at San Jose State for fire behavior. And other tools that we have are we have a mobile Doppler radar, which is uniquely tuned for wildfire. It's a cloud radar that sees wildfire ash and wildfire debris very, very well. And we've been able to take that onto lots of wildfires in the past. So here's an image of our Doppler radar that's scanning actually a crown fire, which was a prescribed fire. And what you see here is the reflectivity and the velocity. So we can actually peer into the actual fire plume and see the structures as they evolve in real time. We can see how strong the winds are in the fire. And this allows us to better characterize the intensity and how the atmosphere and the fire interact. We've been able to actually take this tool to some active wildfires, and here is a video of us on the Dixie Fire where we're scanning the fire in real time from Highway 395 in Eastern California. And where you can see this fire evolving and forming some vortices, or they didn't become fire tornadoes, but they're on the verge of that. So the advantage of having a mobile radar is that we can get to a fire really quickly and we can actually scan the plume and better understand what's going on in the fire. So we've been doing this for over a decade using Doppler LiDAR and Doppler radars, and it's a really shed some light on the dynamics of fire. So, for example, we're able to see indrafts, which are fire-induced winds, and so this is what kind of fuels the fire. Fires create their own weather, and a lot of people have talked about that, but we're actually able to quantify that with our tools on the fire front, basically observing how the winds are changing, observing how the fire is changing. Another tool that we have is called the Swiss. It's a San Jose Wildfire Imaging System, and it's a infrared camera suite of cameras that are integrated into one package using a custom software that was developed at San Jose State, and we can fly that on aircraft to image wildfires, so we can actually see from above what the fire is actually doing. So that's another tool that we have to basically monitor fire behavior in real time. We've flown it on a NOAA aircraft, we've flown it on NASA aircraft, and we've also used it in experiments using helicopters. And so we're getting better technology to observe the fire environment, which then will allow us to collect the data needed to better model and predict extreme fire behavior in the future. So let me share my screen here with you all real quick and just do a little snippet. Okay, so here's this California Canyon Fire experiment where we have an ignition done by CAL FIRE. We have our wind profiler, our mobile meteorological tower here. And the idea is to light this fire outside the canyon and let it burn into the canyon. And
Hmm.
so what we were able to accomplish here is really look at fire behavior in a canyon, which hasn't really been done before. And so one of the things that we have is the Swiss. So here we have the infrared imagery taken from a helicopter using our system of our imaging system. And you can see the fire progress up the canyon and it becomes quite explosive in
Yeah.
certain areas of the canyon here. And so these are really unique observations to have because canyons are very dangerous because they're so steep and as I mentioned earlier, they can entrap firefighters. And so understanding these dynamics is really, really important. And so we've been able to do that in the field.
What kind of impacts do you see on the built environment and infrastructure like utility poles?
Yeah, so what's going on in that space right now is we've been working with a lot of utility companies doing, research and fire weather analyses for them. But within the center, because we are a National Science Foundation University Cooperative Research Center, companies join our consortium and they work with us and they allow us, we provide them research tools and new products, but we get to collaborate with these companies. And one of those companies is Hexion. And Hexion makes a material that they wrap utility poles with.
Hmm.
And so, because utility poles generally are wood and they are at risk in high fire danger conditions or when there's a fire approaching, these utility poles can burn and fail because of the heat and the loss of that pole. And so that's a big problem for firefighters and for evacuation and such because a down power line, if it's still live, can be, you can't cross them. So what they've come up with is this material that they wrap the poles with. And in one of our experiments, we did this high intensity canyon experiment um, in California in 2022. And we're allowed to do is burn this canyon like a wildfire. So we're allowed to start the fire at the very bottom of the canyon and allow it to burn unimpeded all the way up to the top. And Hexion and PG&E were able to place some poles in the canyon and above the canyon to test that material and see how it would perform in a close to realistic wildfire situation, a high intensity fire in a canyon. And so the material works. And those materials can be applied to other infrastructure, housing potentially, other types of wooden structures. So there's a lot of materials out there. There's one of the materials out there that can be used. The poles withstood the fire very well, and they had sensors within the material to look at the temperatures between the pole and the material and outside of the material. And so this is a new technology that could be applied to other wooden structures or other like maybe building structures as well.
What can property owners do to lessen the damage from wildfires?
Yeah, so this is a important question, and we get asked this at the center a lot. Some of our faculty are actually working in this space, working with homeowners and fire safe councils that assess property in certain communities that are at risk. The number one thing is if you have a house in either the wildland urban interface or in the rural area that is at high risk for a wildfire, it's important for that property to have fuel reduction. So defensible space. This is out 100 feet from the home. And what's really critical, and some of the new guidelines in California are really pushing, is 0 to 5 feet have no combustible material. So that would be like a gravel area just around the first 5 feet of the property. And that's really what we're trying to promote in terms of defensible space. And then it can be staggered out farther away from the property where you can put smaller shrubs and such and then get up to trees. But defensible space is really, really important. Another thing that homeowners can do is they can actually keep, if you're under a canopy or in a pine forest, let's say, which we see very often in the Western US, pine needles accumulate in gutters. They accumulate on the roof. They accumulate on around the ground. Clean up those pine needles every year. Keep it debris free. So keep your gutters clean. Keep your roofs totally clean. Because what happens is when you get ember wash or ember fall onto the home or the property, those embers can ignite those needles and then start the gutters on fire, which can start the roof on fire and get under the eave and then can enter the home. And then you now have the house on fire, even though the flame front could be a mile away from the house. Many of our big fires in California and in the Western US, houses are destroyed by embers. More so by embers than by the actual flame front. And so it's important to keep your property clean of debris and of vegetation to limit the risk of an ember igniting something on your property and then igniting your home. Yeah, if we think about extreme fire behavior and especially in complex terrain, we always think of Southern California because those fires they typically are in the mountains. We know this from decades of observing fires in the surrounding area and hills of the LA basin. But that case, while it was devastating and shocking, it wasn't something that the fire community uh, was really caught off guard on because for the week out, the Weather Service was warning about this severe Santa Ana wind event with 100-mile-an-hour winds. I mean, everybody was on edge, worrying about these conditions, and just hoping that there would not be an ignition. Because if there's ignition under those types of Santa Ana winds, we're going to see, devastation, and that's exactly what that unfolded. And so low fuel moisture conditions, um, a lot of homes tightly packed in a canyon. You think about the steep terrain and these narrow streets with lots of houses packed on top of each other. And that strong wind, what happens is once that fire gets ignited in the fuels outside of the community and burns into the community, once those houses start burning, it's not like grass. Grass has a, a short residence time, the amount of time that it's actually combusting, the amount of material. If you see a grass fire, it burns up really quickly because grass fuels are so fine and their mass burns quick. And so then it's over. Whereas a log or a tree or a house continuously burns. And so it's spitting out embers continuously. And so then you start another house on fire, and now that house is catching on fire and spitting out more embers. And it continues and continues as the embers hit the next house downwind. And you have these really strong winds. The embers are traveling down the streets, over through the air, landing on people's properties, and igniting more and more homes. And that's what we consider, that's a firestorm where this thing just keeps going. And it's very hard to stop. That's the problem. There was lots of talk about water pressure and not having enough water pressure. Yeah, that's always an issue if you can't, you know, have the resources for suppression. But again, it's so windy, it may not have made a big difference in some of those critical hours because of the wind speeds gusting to 90 miles an hour, 80 to 90 miles an hour. Um, it's just it's just the worst conditions that you could have where you're in a drought, you have dry fuels, you have lots of tightly packed homes, you have an ignition in that area, and you have extreme winds. So it everything kind of came together for the worst possible situation. It's exactly what we were hoping would not happen.
Thank you for sharing your experiences from your wildfire research with us.
It's a pleasure. Great to be here. Thank you.